Hi everybody, my name is Gianfranco Ruggiero and I'm product manager here at Outfor. Today we are going to talk about how to bridge engineering tool tryout and production in the complete sheet metal stamping process chain. If we look at the timeline of the complete process, we can easily place process engineering tool design together with tool manufacturing and the tryout in the step that it's called product and process development. And then more easily actually we can place the mass production step in what is called production phase together with the pre-series. Now what kind of data actually are exchanged already today between engineering and the tryout? And also the same thing between tool tryout and mass production. What kind of data are exchanged, if there are any? Or is there anything else that together with the die set that is sent downstream to the production plant that should be transferred in order to fulfill production targets? Those are the questions that we are going to try to answer in this short video. So why do we have to bridge them on the first place? Aren't those departments already bridged? And if that's not the case, basically, how can we bridge them in a more efficient and effective way? And then finally, what kind of benefits a company that tries to pursue this goal is going to get? But let's start by answering the first question. Why do we have to bridge those departments? The final destination of the entire process chain is mass production. And we want to fulfill all the requirements, all the targets of mass production. But what are these targets? Well, for sure we want to perform well in production. What does it mean? It means that our process must be capable of keeping the CPK basically at the level that has been required. We want to have low production costs, which means that we want to have a low scrap rate and a low unplanned downtime of the press line. And at the end we want to keep high the quality, because after that those parts are going to be assembled, right? That's what we want to achieve. And today we hear a lot talking about artificial intelligence, smart production, and so on. But are those principles just applied to the production plant? Well, everything starts from the engineering. Engineering is the first step of this process. So data can flow and should flow from the engineering to tool manufacturing at the very beginning, let's put it that way, in order to ensure digital twin and physical twin. We are talking about smart factory because we want to inquire the digital twin to get answers about the physical twin. So how to modify things during production in order to lower the scrap rate or lower the unplanned downtime, as we said. Now, if we can achieve these two goals in engineering and then in tool tryout, we have to transfer downstream also this data, not just the die set, but the data that can help people getting those targets fulfilled in production. This is something that today doesn't happen, or doesn't happen all the time. So basically, how can we improve and what kind of data we are supposed to transfer from one department to another? So we move to the second question. How can we bridge them in a more efficient and effective way? But what kind of benefits I'm going to get if I embrace this approach? Well, benefits are multiples, are severals. We can mention, of course, the reduction of the tool tryout efforts in terms of time, in terms of cost, in terms of loops, basically. Increased tool quality, the quality of the tool that you send downstream to the production plant. And consequently, you increase the production quality, you reduce the scrap rate and the planned downtime in production, and you reduce the overall lead time. But this doesn't come for free, let's put it that way. Bridging engineering, tryout and production means that you have to embrace the design robust manufacturing process, which is and must be a company-wide attitude. You cannot apply it just spot-like. This is the only way that you can have a head start in implementing smart manufacturing, smart production. So how can we improve this process? What kind of data we have to generate? Everything starts from the engineering. And we suggest you to embrace what we call robust manufacturing process design. What does it mean? It means that during the engineering phase, you have to consider the variability of some process parameters, like material, lubrication, and so on, because that's the way it occurs in reality. And when you transfer that data, that sensitivity analysis of these parameters downstream, then you can apply the smart tool manufacturing, let's put it that way. But we have to transfer what we call the digital predicted tryout data. So tools that are going to be modified in tryout are modified according to the engineering intent, so that the process capability that has been engineered is ensured during tool tryout. And only if we do that, then we can transfer additional data downstream to the production plant to help and to support production. So thank you for your attention and thank you for watching the video. If you want to have more information, please get in contact with myself or get in contact with your local AutoFirm office. Thank you again.